In this lesson, we're going to learn how to solve quadratics using what we call Loh's method, or at least what I'm going to call Loh's method. Loh is just the professor who invented this method, so I'm giving him credit. First, let's review some vocabulary. Two important things are solutions. Remember, that's where the graph crosses the x-axis. And the axis of symmetry is where we can cut a graph in half, like the line that does that. So it's like this, goes right through the vertex point, and it cuts the graph in half. The equation that we have for it is x equals h, which is equal to negative b over 2a. Okay? So those two vocabulary terms that we've talked about before are going to be really important here. And so Loh had this theorem, we call it. And so I'm going to give you an actual example here, and then we'll kind of generalize it over here. And so on this graph, let me make my pen a little bit thicker here. On this graph, if we draw my axis of symmetry, so that's the line that cuts it in half, so it's going to be 4. So this is x equals 4, which is my axis of symmetry. And I also see I have these solutions. So I have x is going to be equal to 2, and x is going to be equal to 6. And so one thing that I notice is that each of these 2 points, so 2 is 2 spots away from 4, and 6 is 2 spots away from 4. So this is 4 plus 2 to get to 6, and 4 minus 2 to get to 2. And so the solutions are equal distance away from the axis of symmetry. And so to kind of generalize it here, if we draw our axis of symmetry the best we can, and I've got my 2 solutions here. Okay, these 2 solutions are some distance away that we can call d away from the axis of symmetry. So this will be minus d and this will be plus d. And so we can figure out what those 2 solutions are if we find the axis of symmetry and find that distance. So we're going to do 2 examples, and I've got the steps here for this one. My first step, like we talked about, we're going to find that axis of symmetry. So we've got the equation h is equal to negative b over 2a. So I'm going to say this is a is equal to 1 because it's the number in front of my x squared. B is equal to 6, and c is going to be equal to 7. So h is going to be negative 6 over 2 times a, which is 1. And so negative 6 divided by 2 is going to be negative 3. So I'm done with step 1. My axis of symmetry is negative 3. Now we're going to find the distance. We're going to find d, we call it. And we have this other formula. D is going to be equal to negative c over a plus h squared. So let's do that. I'm going to set that up. So d is going to be negative. My c is 7 over my a, which is 1, plus my h squared, my axis of symmetry, is negative 3 squared. Okay? 7 over 1, or sorry, negative 7 over 1 is just going to be 7. So I'm going to write this as negative 7 plus negative 3 squared is negative 3 times negative 3, which is going to be 9. And so negative 7 plus 9 is going to give me a positive 2. So the distance is going to be 2. And so like we were talking about, those solutions are going to be plus, is going to be from my axis of symmetry, plus the distance and minus the distance. And so we can find our 2 solutions by saying x is going to be equal to my h value plus and minus the square root of d that we found. So we can do that. We can say x equals negative 3, which was my h, plus and minus the square root that we found was 2. And my third step just says to simplify. In this case, we can't. So that would be my final answer. Okay, so this is a pretty straightforward example. But we can also use this when we get messier numbers or like complex solutions too. So let's look at an example of that. again, I've got the steps here. So let's find the axis of symmetry. So a, the number in front of my x squared, is going to be 5. B is the number in front of my x, which is -2. And c is going to be my constant, which is 5. Okay? What I'm going to do is I'm going to plug this into Desmos now. And so I'm going to say a is equal to 5. I'm going to say b is equal to -2. And I'm going to say c is also equal to 5. Okay? So now we can find h, right? And the calculator already recognizes these values as a, b, and c. So I can say I want -b over 2a. And it gives me 0.2. When we're dealing with fractions, when we're dealing with decimals, I'd rather deal with a fraction. So I can click this button and convert it to a fraction to be 1/5. Okay, so let's come back to the notes here and say my h is going to be -b over 2a, which we said was 1/5. Now let's find d. D, we're going to say, let me change colors here, is -c over a plus my h squared. So let's jump back to Desmos now. And so I can also just plug this straight in, and the calculator will also recognize h as 1/5. So all I have to do is type in -c divided by a, and I want plus h squared. And it's going to give me -0.96. I want to convert that to a fraction again. So my d is going to be -24 over 25. Okay. So now my third step is we want h plus and minus the square root of d. Okay. So let's see what that's going to look like. I've got 1/5 plus and minus. When I take the square root of a fraction, it's the same as taking the square root of the top and the square root of the bottom. So I'm going to write this as the square root of -24 over the square root of 25. Now I can simplify. And I'll do this in my tan pen. Square root of 25. That's just 5, okay? 25 is a perfect square. And so I'm going to make this one fraction now because my common denominator is the same. So I'm going to have over 5. And I'm going to have 1 plus and minus. Now we have to break up this square root of -24. Since it's negative, I can go ahead and take the I out because it's going to be imaginary since it's the square root of a negative number. So I'm going to have the square root of now 24. And I can break 24. We can do it maybe out here. 24 can be broken into 2 times 12, which can be broken into 3 times 4, which can be broken into 2 times 2. And so I have a pair of 2's here, which will come out. So I'm actually going to erase this I. So I'm going to say 2i. And now left inside the parentheses, I've got 2 times 3, which is 6. And I would check and see, can I simplify these 3 numbers, which in this case I can't. So this would be my final answer. Okay, so this Loh's method works when we have complex solutions too, nice numbers and complex. I think it is pretty straightforward, especially if you use the calculator. And so we can use Loh's method to solve any kind of quadratic, whether it's real solutions or complex solutions. All we're doing is we plug in our a, b, and c. We can find our h, our axis of symmetry, which we've done before. Then we have a formula that we're going to use for the distance, and then our solutions are just our axis of symmetry plus and minus the square root of that distance. So I think this is easier than the quadratic formula personally. But if you haven't watched the quadratic formula video, then you can go ahead and watch that and see which method you like better yourself. So I hope you had as much fun as I did learning about Loh's method. Good luck in your practice, and I'll see you in the next video.